All right, folks, you guys made it to the long haul. Right up after this are going to be the lightning talks. I don't know if you guys have seen the board out in the corridor. Just go straight ahead. When we're done here, there are a whole host of pretty tasty lightning talks for you guys to go ahead and choose from. Before we get started, how many folks saw Jackie's stellar talk a while ago? Holy crap, did you not punch your ticket to the party train? Jackie just gave an excellent introduction to natural language processing about a session ago. So if you guys want to go to the PyGotham website and check out her video, it's a really, really good introduction to the discipline that we're going to be talking about for about 40 minutes or so. How many folks know what natural language processing is all about? Boom! You right there. What is it, dude?
Natural language processing is about programmatically analyzing human speech.
That's a that's a great way of putting it.
My talk was on natural language processing.
Yeah, I saw you were using text blob too. We're doing a crap load of text blob today, so you should be stoked, brother.
All right.
Yeah, natural language processing. It is pretty interesting, mostly because it is damn difficult. It is this mathematical collision of computer science and linguistics to try to take the genetic predisposition that each one of you guys have to comprehend human language and turn it into ones and zeros that we as programmers can manipulate. Why is it so hard? Glad you asked. Mostly because language is delightfully and beautifully ambiguous. So never mind the 6,500 different spoken languages that are out there right now. Let's just focus on English. English, holy biscuits, is terribly ambiguous, right? So let's say, for example, this sentence. Let's say Rob and Nate took 2 trips to Boston, and they were both wonderful. Well, who was they? Right? Were the 2 trips wonderful, or were Rob and Nate wonderful? I hope it was Rob and Nate that were wonderful, but it obviously depends on the person that's saying it, right? Another good example, I watched the Enterprise hover over New York. Now, if you're a computer programmer, or if you're a computer program, rather, and you have never watched Star Trek before, it's going to be kind of difficult for you to understand how an Enterprise could ever hover in any circumstance. And further, like, when could Yorks become new? Like, it starts to become really, really complex, right? Prepositions make this even worse. The canonical example from the discipline of NLP is, I saw the man on the hill with the telescope. Did the hill have a telescope, or did the man have the telescope? Like between pronouns and prepositions and syntax and inflection, all these things become super, super difficult. The words themselves are super hairy. The Oxford English Dictionary has 26 definitions for the word bank. All of them are completely different. It's a really, really hard problem. Really hard problem to solve. And when you think about postmodern software right now, given how hard natural language processing is, it's little wonder then, basically any software that's written with it basically has it as the primary feature, right? Like when you think of all the good software out there that has NLP, basically the natural language processing is the only damn feature of the software, right? So if you look at Google Now or Siri or Cortana or whatever the broken stuff is that's running on this watch, right? Like the language processing is the only piece. And I think us in this room as Python programmers have an awesome opportunity to leverage this computer discipline in improving the existing features of our applications rather than replacing them wholesale with a natural language interface. Now, a user experience that I work with every day at Twilio is text messaging, right? And if you think about text messaging as an interface, it's pretty basic. It involves a whole lot of language, and it really hasn't changed in like 20 years, right? Any text messaging application that you've ever interacted with, there's always like this capitals keyword that you're always talking to, right? And this has been the way it's been since SMS has been around. And so what I'd like to posit to this group is perhaps we can use NLP to make this 20-year-old use case a lot more interesting. And in so doing, evidence that we can take this field and take the vibrant Python community that has grown up around it and have a lay programmer actually apply it meaningfully in the field. So, my name is Rob Spectre. I have the privilege of serving on the developer evangelism team for a company called Twilio. How many of you guys have heard of Twilio before? Awesome. So what do we do? I don't know. Hey, I'll take it. I'll take it for that. We, for the folks that may not know, make it really easy for programmers of any stripe, especially Python programmers, make it really easy for you to send text messages and make phone calls directly within the software that you're already creating. How many of you guys know how it works? Okay, so that's going to be important for the context of this talk. This is not meant to be a pitch. I'm just telling you because you're going to need to understand the code. So the way Twilio works is you buy a Twilio phone number and it sits in the Twilio cloud. At any time someone makes a call or sends a text message to that phone number, Twilio makes a request to your web application. You respond with some very simple instructions and then some crazy magical stuff happens. So if it's okay with you guys, I'd like to buy a Twilio phone number right now. And we'll write some software that will allow us to perform natural language processing on the text that all you folks send in. Does that sound like fun? Yeah. Cool. Do you guys got your phones out? Yeah. Groovy. Let's get going. Some code. So first, we're going to go get a different number because Rob wasn't super great about setting up his station here. And of course, my little Wi-Fi puck was working super great over on this side of the room, so we're going to move it over there. Cool. And we're going to get this ungreenified. That's Kermit the Frog interface. It's not going to be super great. Oh. Whole thing got off here. Stay on target. There we go. Cool. Okay, so we're in business. Okay, can everybody not really see that? There we go. That looks good. Alright, so we're back in business. Why don't we go ahead and use Twilio to buy a phone number. So just for reference, everything that we're going to be doing today is going to be completely from scratch. So absolutely no slides, just buying a real telephone number and going from there. So we have a fairly sizable group in the crowd today, so we're going to go ahead and buy a toll-free Twilio phone number, which will allow us the ability to respond to you guys at the rate of 3 messages a second to make things super speedy. And we will go ahead and configure our messaging request URL to point to a tunnel that I'm going to set up on this laptop that we're going to interact with from this number. Could I get somebody from the crowd to write this number up on the board? Or I'm going to go ahead and do it. It's all good. Let's set this on the board so you guys can start working with it. That's 855-976-1449. There we go. Cool. So we got ourselves Twilio phone number. Now we need to set it up so you guys can do some interaction with it. For that, we're going to cut some Python code. And that Python code, I saw a whole bunch of stickers for Flask, so we're going to go ahead and do it in that today. We're going to grab a helper for our Twilio responses from the Twilio Python module. We're going to go ahead and instantiate a new Flask app, right click, and create a route for that Flask app that's going to respond to Twilio's post requests with a TWIML response
Do you mind bumping the light size a bit?
You need it a little bigger?
Oh, it's good.
Cool. Is that better for you guys?
Yeah.
Cool. And we're just going to respond with a quick message saying, "Howdy folks, thanks for coming to my talk. Find me at Twitter at DL0T.
API would be on both ways.
Yeah, so that's the funny thing. That's the sound that text messages make. I don't know if they do that. It's true. We're going to finish up with a little boiler code. A little boilerplate code, rather, where we're going to set the app to debug, and then we're going to make it rounded. And we're not going to return the message. We're actually going to cast that response as a string, and it's going to give Twilio the information it needs. And then we're going to go ahead and fire that application up. Then we're going to use a tool called ngrok, which is going to take port 5000 on my machine, publish it to tunnel.brooklynhacker.com, which is going to respond, hopefully, to all your guys' text messages. So watch you guys, move out your phones. Send the text message to the number I hope you loaded in your phone. It's 855-976-2149. Number is 855-976-2149. Shoot it a quick text. Turn this up so you guys can hear my ringtone. Bop, bop, bop. For those who have Verizon service, you're going to have a lot more fun during this talk than the folks that have AT&T, I assure you. Did you guys get a little response back? Yeah. Okay, so we're almost there with the setup for the project. We got a rig working to get your text messages. Now we need to grab some stuff to do some natural language processing on it, which will involve getting the Flask request object. Then we'll also get the text blob object, which is a NLP library written by Stephen Loria, which we're going to use today to demonstrate some of this tasty fun. So we'll adjust our SMS function to grab from the request object, and it keeps all the post parameters in a dictionary call form. The body that Twilio is going to give us, we're going to take that body and drop it into a text blob, and then we can do some crazy stuff. Like we can, let's respond with a message that says that had this many words. And we'll go ahead and take the length of the words list in the blob and return that back to you guys. And then we're going to do one more thing. In order to make this a little more visual, a little more interactive with you guys, we're going to use the Flask debug log to print out everything that you guys send to me. And then also print out everything that I send to you. We use that by passing the body that you send to me. And then we're going to go into our response object, descend into that data structure, and grab the body of the text message that we ultimately send you guys. We're also going to make sure that that's in that big, because that's the way Jesus intended to write Python. So, if you guys send a message with a few words in it, we should see some stuff on the screen.
Yes, first.
Right. Bacon is the new bacon. 1352, that had 4 words, that had 2 words. Cool. All right, so we got a rig. We got a rig, right? We can take our phones, we can perform some basic natural language processing on it. So what you're seeing on the screen right now is called what in NLP? What does this fit right here? Does anybody know? It's called tokenization, right? It's taking a string and breaking it down into the token components that have linguistic significance. But we can do quite a bit more than that. We can also grab some specific tokens based on their classification, based on their tagging. So we could grab their proper nouns. Right? Did you have a question, Seth?
No, I was going to make a suggestion. You should totally use the sentiment analyzer and then pass back a message saying, "Are you feeling happy or sad?"
Dude, spoiler alert!
Are you using Python?
Dude, you're the guy that ruined Game of Thrones for us. Aren't you?
I'm so sorry.
Are you using Python?
I am using Python 3.
I was trying to do something.
You were trying to do some Unicode to bust up my code?
Yes.
Dude, it's 2014. You can't play those hacks anymore. Actually, this is a really good moment to thank Stephen Loria, Armin and the Flask crew, and everyone at NLTK for making sure that their library supports Python 3, because otherwise this code would look a lot uglier than it does. Python 3, it works, folks. So what we're doing here is we're going to take the proper nouns. So we're going to look through all the tags in our blob, and then we're going, so this tags list is a list of tuples that include the word that we're going to grab, and then its classification. So in this particular case, I want to grab the classification, which is a 3-letter code that signifies a proper noun. And we're just going to cast that list as a string. I'm not doing any crazy formatting. So we go back to our bit, and you guys send me a message with some proper nouns in it. We see buffalo. And here, we only have 2 that are capitalized, which disambiguates them as proper nouns from the regular capital that run around. We have greetings, beaker, whole bunch of stuff coming in. New York, I found these proper nouns. That's good stuff. Cool. Right on. So, we got a rig. It's able to take a look at words. It's able to define some meaning from those words. How about we go ahead and do some sentiment analysis? It's going to be a great surprise. Sentiment. So, for the benefit of the audience, can you just tell us what sentiment analysis is?
Sentiment analysis is when you assign numerical value to a sentence or a set of words, whether they're positive in nature or negative in nature. So the world is wonderful and amazing would have a very high positive sentiment analysis score, or the phrasing something like, I hate the world, die, 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 would be like super negative and have a low.
Oh, let's find out. Let's send those 2 messages to that number and see what we get in return.
Does it work with different languages?
That was a great message. It's working. This is currently set default to English, and choosing the sentiment analysis package from Pattern, by the way, underneath it. So if we take a look, die, I hate the world has a polarity of 0.8, but it also has a subjectivity of 0.9, meaning it's saying that I'm very sure this is not a very positive thing that you're saying. Yeah, 7C is at least kind of positive, but we're not super confident about it with a subjectivity of only 40%. So do we understand the difference between polarity and subjectivity? Polarity is how positive or negative the statement is. Subjectivity is the analyzer's confidence that that is the case. Make sense? Cool. So why don't we go ahead and do something that would be a real-world example of this being useful. Like we could take a look at that sentiment, and if the polarity was above 0, that is to say that it was positive, we could pass you a message saying, awesome! I'm stoked that you're stoked. And then, if that sentiment polarity was less than 0, I could respond with a message that says, railer, I'm bummed that you're bummed. And if we could not gather the polarity of the sentiment at all, we will respond with a meh. All right, let's shoot some messages and see what we see. Eat my shorts, man. I'm happy to be here, aren't you? I'm stoked that you're stoked. The world is very lonely. That is definitely not a positive thing. But I'm a wanderlust king. Unfortunately, sentiment on Google Bordello lyrics is very difficult to get. But thank you very much. Life is good. I'm stoked that you're stoked. So as you can imagine, when you're building a text messaging app, based upon the positivity or negativity of the people that you're speaking with, your application may want to respond a little bit better. And as it turns out, because you guys are Python programmers, that code is not very difficult to write. Look, we made that determination with a single if else statement. Isn't that pretty crazy? And that's pretty rad, right? Let's talk about fat fingers, because I have them. Fat fingers are a very serious problem with text messaging apps, right? So if nearly every text messaging app that you have ever used has had this statement, for more information, text help, right? So if you guys shoot a text to the number now, you're going to get an indication that you should text back for help. And if you do that, you know, some coder is writing an if-else statement that tries to take a look whether or not you're using that keyword and respond with an informational message, or respond with an indication that if you want that information, you need to text me a keyword, right? Now, this has a pretty serious problem in the sense that smartphones have actually made this, ironically, harder, right? So if you text something that is not help, why does this keep getting bigger? Boop. There you go. If you text test, it will give you an information message. But if you text help, it will go ahead and give you the informational message. But as you guys are typing in with your fat fingers, help, me please, is obviously not working. Every single text messaging app that I've written has a whole bunch of helps in it. And the reason why is iOS, Android, and Windows Phone only initiates autocorrect when you provide a punctuation or white space delimiter. That is to say, try to misspell help on your phone right now. It will not autocorrect until you hit a space. Guess what you're not hitting when you're submitting a keyword to an SMS app? Smartphones have actually made SMS dumber. But you can save the world from this circumstance by using a little autocorrection, by taking a look at the word and defining what the user might have intended. So what we could do is check and see if the user is only submitting one word in the message. So that is to say they're using a keyword. They're clearly trying to commit some sort of operation. And then we can take if help, the blob, make it lowercase, and correct it using natural language processing. Respond with an informational message. Or tell the user to provide that keyword if they want to get that message. And then we'll cover the corner case here by saying one word. So if we save that guy, scroll down, we can see that we have solved just a few lines of code the HLEP problem, which is good. We can totally biff it and not even have a vowel in there with HLEP. But others like HORK and HALP that may have closer affinities to words like half, obviously can't be solved for. However, out of all the misspellings that we see here, we're hitting at least 80% of them. So again, NLP can knock down a whole lot of unintentional fat finger errors in your users' applications. That's pretty rad, right?
Yeah.
All right, would you guys like to see some more?
Yeah.
Cool, cool. Let's talk about the sharing economy. So the sharing economy is pretty big right now, and at Twilio we are pretty lucky to have a lot of customers that are doing this stuff now, and they're doing a lot of the stuff over text messaging, right? And the use case is exactly what you would expect it to be. Like if you see they're connecting buyers and sellers in a decentralized network. So you can imagine people texting into a text message app looking to buy something. And the text message app says, cool, I'll connect you with sales. Right? And if they are trying to sell something, we can respond back, rad, I'll connect you with merchant services. And if we don't know what they're trying to say, we'll say, derp, derp. I can't understand language. Now the problem here with that naive implementation is pretty obvious, right? So you can say, I want to buy an amp. Right? And you can send that in. And you can also say, I want to sell a guitar. But if you say, I sold a guitar, didn't get paid, like A-frame picture of the hop, what the heck are you selling? I think you guys are getting this. I sold a guitar and didn't get paid. You can see, obviously, that the code didn't work because it's not attuned, it's not understanding the language. Right? Now, sold is one of many, many examples of the English language of what we call irregular verbs. These are verbs whose past tenses and future tenses have dramatically different spellings than its present tense. Right? However, at the core of this word is a psycholinguistic token. That is to say, a core root of the word that you all, by virtue of your genetics, immediately associate with that word. So if you are selling something, right, or you sold something, you're still talking about this psycholinguistic lemma, the root of the word, that is associated with sell. So if we had a natural language processor to perform that lemmatization, we'd be able to make more intelligent responses to our users. So how about we go ahead and give that a try right quick. My Windows bouncing all over hell and breakfast. And for this, we're still going to be using a text blob interface, but we're actually going to get a new interface from NLTK because its part of speech tagger is a lot better. We'll go ahead and instantiate that NLTK object, and we're just telling text blob we want for any POS tagging that it does to use NLTK instead of text blob itself. And then we can take this naive implementation and improve it a great deal, right? So we could go through all the verbs that we have in our blob. And if we see that it is a verb, we're going to go ahead and drop it in this list comprehension. And if we find some verbs, we're going to go through each of them. And if by is the lemma of that verb, we'll pass a message saying connecting you to sales. And if sell is the lemma of that verb, we'll instead connecting you to merchant services. We'll cover one obvious edge here, just saying derp. Say that guy. Oh,
Missed the quote.
Oh yeah, totally missed the quote. Anything else?
Take that for hunters.
Definitely. That shows a crash with the reloader. Cool. All right, so now if we look at our phones and say, I want to sell a guitar, and I sold a guitar, I'm going to end up, hopefully, going to the same place. Uh-oh, 500 internal server error. What the biscuits? Sold weed last night, so we have some guests from New Jersey. That's great. I want to sell my soul. I sold the guitar connecting to merchant services. Right? Now, the reason why this becomes important is not necessarily for the simple case of a binary choice between buying and selling. The reason why it becomes important is because that's not all this application is ultimately going to do, right? Let's say we want to add the ability to trade to our application, right? Trade and trading are obviously two dramatically different spellings, and as your application grows, you can imagine that the complexity of maintaining that code base, so too is going to grow with it. So in this particular case, NLP is actually saving us a whole bunch of time, because if I say I am trading in my guitar, with just a couple lines of code and an easy to read format, you can hopefully see. Definitely didn't cover the corner. That even though we did not spell trade the same way that we did in our individual argument, through the power of natural language processing, we were able to define the user's intent and route them to the appropriate place. Does that make sense? Cool. Choose your own adventure time. Would you guys like one more example, or would you like to take some questions? We only have time for one of those two.
Can you actually do something where instead of using a lemma, you can actually use something like WordNet to actually get at like synonyms?
Totally can. Yeah, that's definitely available. A WordNet object is available for every text block that's out there. So you can get the level of confidence in each of those as well.
What's the benefit of using text Blob versus using that field and became easier to use?
Yeah, it's really just using use. At least in my experience, that's what I found. NLTK is going to give you a lot more control and a lot more precision over the bit. Pattern is also going to give you a lot greater speed over NLTK. Quality is not necessarily something that you're worried about. Text Blob takes both of those two worlds and makes it very easy for you to write out basic functionality and demonstrate it to a crowd, for example.
Do you get on the corpus?
Say what?
Do you get on the corpus?
Yeah, it actually downloads the NLTK corpus. Like it has a function called download corpora. It'll download all the NLTKs, like the movie reviews and all the stuff that's built into NLTK. And that's what TextBlob ultimately uses. Really, what Stephen did with TextBlob is turned the rights inspired for humans interface and addressed it to this specific problem.
It's a wrapper, a nice wrapper.
Yeah, totally.
So the tags that you were referencing, those are all the tags that you get back from if you parse a piece of text that you put into text block, right?
Yeah, that's totally right. So the tags list is a list of tuples, and I can go ahead and show you what that looks like. I know that's a little obscure. If we open our Python interpreter, grab text blob, create ourselves a text blob. This has many parts of speech. The blob tags will give you each word and what it tagged it as. Now, the reason why I switched to the NLTK tagger is because the part of the speech tagger is superior to the pattern implementation. So I want to demonstrate that you have that flexibility. Many libraries to choose from. Any other questions? I got 10 minutes. I want to sneak in one more example. Are you guys okay with that?
Yeah.
All right, cool. So, internationalization. So I'm going to get a little bit on my high horse a bit and show you one of the things that I hate most seeing in the world. And that is the example of a text messaging application that has a bifurcated language structure. So they'll say, for information, more information, text help, and then they'll follow that with para más información, texto ayuda. Lo siento, mi pronunciación está muy gringo. Okay, but if you go ahead, someone should have texted that if you don't mind, and I can kind of show you the problem. So last year, or earlier this year rather, the telecommunications agency for the United Nations released their estimate that there were 6.8 billion cell phone subscriptions out there. That is to say, there are 6.8 individual calling plans that are set up to these devices, which almost assuredly makes the cell phone something that now outnumbers the total number of human beings that we have on planet Earth. Right, this is a global phenomenon. It's one of the few technologies that can reach that many people. There are only 4 billion internet users total on planet Earth. There are only 1.2 billion smartphone users on planet Earth. There's absolutely no other technology that we have that has the reach of SMS. And when you take a look at this is a pretty serious problem, right? Because at any given moment, you're not addressing the entire audience with the phrase. And further, there are cognitive studies that suggest that users of the following language will feel intimidated because English is spoken, right? And they will use the inferior interface, right, almost 60% of the time over the interface that was actually created for them, just by virtue of it being placed in front of the Spanish string. Right? Now, with natural language processing, we have everything we need to know what language they're speaking because they're telling it to us. It's in the language of the text message that they're sending. So let's go ahead and use the Google Translate API to create a more human interface here. And what we'll do is we'll check, and fortunately TextBlob has this built in with the detect language function. What this will do, we'll kick off a HTTP request to Google Translate's API, and for all our Spanish messages, we're going to respond, lo siento por mi Espan.
Almost.
Oh, god damn it. Yo, terrible. And if not, I'll just respond, I am very sorry for my terrible Spanish.
You need to fix your response. Give response.
Oh, totally. You're right, dude. Douche. Now, if you send the classical question that you're going to ask after one of my talks, ¿Dónde está el baño? You'll get the Spanish message, and then if you send a few more words than just hola, you should be able to get an indication in English. Question marks, they're very American, clearly. Cool. So, right, guys, that's all I had to show you guys today. When you're thinking about natural language processing, this is not an all or nothing thing. And you as Python programmers have a unique opportunity to leverage it. The best work in natural language processing in this field that will be the future of the interfaces that you and I create for the rest of our lives is being done in Python right now. And even as a lay programmer, not a computer scientist or not a mathematician, you can use these tools right now, not to create the next Siri, but instead to create a more human interface in the software that you guys are already creating. My name is Rob. I'm at Twilio. All these talks are up on my GitHub, and you can hit me up at Twitter if you have any more questions. Thanks a lot, Ian.